Bismillahirrahmanirrahim. So today we are back with another important lecture. ये एक बहुत ही important topic है as far as the polymer chemistry is concerned. Last lecture में हमने देखा था the number average molecular mass of a polymer solution can be determined by the end group analysis. उसमें हमने basics discuss किया था. This is another important method that is used to determine the number average molecular mass of a polymer. That's called as the viscometry. So this is called as viscometry. इसमें objectives entrance में भी questions पूछे जाते हैं. So this is one of the important topics. तो viscometry में जैसे मैंने यहाँ दिखा, it is used to determine the number average molecular mass of a polymer. ठीक. Now viscometry जो है, it's one of the fastest methods. It's very fast method. This method is very fast. And then it's commonly used lab में जो हम practicals अक्सर कराते हैं, that we basically show this viscometry. And this is also one of the cheap methods. So this is one of the fast method and a cheap method for determination of molecular mass of polymers. That is the number average molecular mass of polymers. इसमें what is the principle of this method? Principle is very simple. जब भी हमारे पास, for example, we have a pure solvent. Let us say pure solvent like water. Pure solvent, it has very, very low viscosity. And that viscosity is expressed by eta. Now, in this, if we add our polymer, let us say this is polymer present in the solvent. Now the viscosity of this changes. Rather, the viscosity of the solvent now increases. So there's an increase in the viscosity whenever we have the polymer present. Now the viscosity of the solution can be expressed as eta 0. So this is the viscosity of the pure is expressed by eta 0, जो अक्सर books में होता है, and viscosity of the solution is expressed as eta. So this is the viscosity of polymer solution now. That is polymer solution. When we say polymer solution, it means polymer plus solvent. Polymer plus solvent. So this is viscosity of pure solvent. So viscosity of the solution increases when we are adding when we have the polymers present. You have basics. Now this change in the viscosity, when we have the polymer present in the solution, that is used to calculate the molecular mass of the polymers. So what we do, we determine the molecular mass of polymers with the help of an apparatus or with the help of a glass apparatus or a very simple instrument, that is viscometer. यहाँ पे देख सकते हो, this is called as a viscometer. ये practical हमने दिखाया भी है. We have uploaded the lecture also, so you can please see that. So this is a typical viscometer. इसमें दो arms होते हैं. This is one arm, this is another arm. जिस fluid का या जिस liquid का या जिस polymer solution का हमें निकालना हो molecular weight, so we are basically adding it through this arm. तो इसमें दो bulbs होते हैं, bulb 1 and bulb 2 here. And then there's this arm also outside and to maintain that pressure. Simple. ज़्यादा मैं यहाँ discuss नहीं करूँगा इसका. So what we do when we add, for example, we have to determine the viscosity of our pure solvent. So we add the pure solvent here. And जैसे यहाँ भरा हुआ है. उसके बाद what we do, यहाँ से हम इसको suck कर लेते हैं from here. So we'll suck this with the help of a bubbler or with the help of mouth. अगर ये toxic ना हो, तो यहाँ तक हम इसको रीडिंग में M1 तक सक कर लेते हैं. उसके बाद once it reaches this M1, उसके बाद we are releasing this. उसके बाद हम देखते हैं how much time it takes this liquid to come from this level to this level. That's M2. So let us say the time it takes, that is T0. तो हम time calculate कर लेते हैं. इसी तरीके से now we have the polymer solution whose viscosity is eta. We are adding that polymer solution. We do the same exercise. We'll suck the liquid and then we'll calculate the time it takes from the polymer solution to reach from this to this. the time period is t. Let us say it is t. So, यहाँ तक तो आ गया that with the help of viscometer we are basically calculating the viscosity. How we do that? So we are basically now अब इसको मैं थोड़ा सा मिटा लेता हूँ, so because it has so many relationships here. So with the help of this towards this viscometer, we actually calculate the relative viscosity. That's eta r. That relative viscosity is basically, that is the viscosity of our polymer solution divided by the viscosity of our pure solvent. That is equivalent to the time it takes. So that is T divided by T0. So हमने यहाँ कहा था कि ये है the time the polymer solution takes to come from this point to this point. And this is the time pure solvent takes to come from this point to this point. We know जिसकी viscosity ज़्यादा होगी, obviously that takes more time. So they have a direct proportionality. So relative viscosity can be calculated by this time relation. So this is basically the viscosity of polymer solution, this is viscosity of pure solvent. So from the Osterwold's viscometer, we are basically getting a relative viscosity. So we have calculated relative viscosity from the viscometer or from the Osterwold's viscometer. That relative viscosity is eta r. Fine. Now this is one. Of relative viscosity, chunki that is equal, that's the ratio of this by this. We know polymer has more viscosity, polymer solution, than this. So that means the relative viscosity value is always greater than 1. Fine. So this is important. It's always greater than 1. And if you have more, what we say that if the concentration is usually more than you express more, then you actually think that relative viscosity is always greater than 1. It increases with increasing the polymer concentration. Now, relative viscosity is a better term here in order to express the viscosity of polymer solution. That term is specific viscosity. तो हम relative viscosity को convert करते हैं into specific viscosity. What is that specific viscosity? It is basically जो आपका relative viscosity है term, write it like this -1. So हम इसको ऐसे भी लिख सकते हैं eta minus 0 by eta. Now what is this? This is the viscosity of the polymer solution. This is viscosity of pure solvent. That means the change in the viscosity जितना हमने polymer एक solvent में add किया. So this is basically the change in the viscosity. There's increase in the viscosity relative to the pure solvent. So this is now called as a specific viscosity. So specific viscosity is basically change in the viscosity, increase in the viscosity. This is your term specific viscosity. तो हम relative viscosity को convert करते हैं into the specific viscosity. Fine. तो इसको हम या ऐसे भी एक्सप्रेस कर सकते हैं क्योंकि ये बहुत ज्यादा इंपॉर्टेंट है ना, इसमें क्वेश्चंस आते रहते हैं. This is your relative viscosity -1. So that also is equivalent to the specific viscosity. तो आप इसको बहुत सारे टर्म्स में अंडरस्टैंड कर सकते हैं. So this is also the same, this is also the same, this is also the same. So now we have converted the relative viscosity into the specific viscosity, that is the change in the viscosity or increase in the viscosity of pure solvent when we have the polymer added or when you have the polymer present with respect to the pure solvent. So we have converted relative viscosity into the specific viscosity. The specific viscosity ho ya relative viscosity ho, in both the cases the viscosity increases with the concentration. But इसमें एक problem ये आती है that it has been observed that relative viscosity and specific viscosity जो है, so both relative viscosity and specific viscosity जो है, the viscosity change is rapid. So the viscosity change is rapid. Since the viscosity change is rapid, it is difficult to calculate the molecular weight from this term. So what we do, we convert this into another term. So we're basically converting the specific viscosity into another that's called as a reduced viscosity. क्योंकि reduced viscosity के case में we want that term that should not change rapidly, rather it should be there should be a regular change with increase in the concentration. There should be a regular change in the viscosity with increase in the concentration, and for that we are expressing the viscosity in terms of reduced viscosity. So how we can convert the specific viscosity into the reduced viscosity? So what we do is that we are actually dividing the specific viscosity by concentration. So the specific viscosity, when we divide this by the concentration, so that term is basically your reduced viscosity. So we're having the relative viscosity, that is the ratio of this by this, and then we converted this into the specific viscosity. The specific viscosity was converted into the reduced viscosity by dividing the specific viscosity by the concentration. Now that means the specific viscosity with respect to concentration. Now ये जो term है, it's not rapid. This varies regularly with the concentration. So if we plot, now let us plot that. So if we plot specific viscosity with respect to concentration, so now I will just rub this. So in case you missed, you can go back. You can actually go back in the video and you can go back and check that. So if you plot this is your concentration, and that is gram per 100 ml concentration. So you are basically varying the concentration, and then here you are checking the reduced viscosity. So your y-axis is the reduced viscosity. Fine. So if you plot this for various concentrations, for example 2, 3, you could see there's a regular increase. So that means with a regular increase in the concentration, the reduced viscosity increases. Fine. Now that means since it always comes a straight line, so you can express it in the form of y is equal to mx plus c. So this is your constant. Fine. So what we write, we'll write reduced viscosity here. That is equivalent to slope of the line. That slope is basically specific viscosity by concentration, because reduced is specific by concentration. So you will write it specific by concentration. Take. So that is your mx plus c. So that is m, x is your 1 by c plus c. So this is your equation of the straight line. So this is m, your x is 1 by c. And remember this you should not get confused here. This is basically the constant, this one. You show it bold. And this is basically the smaller one, that's the concentration. Fine. So this is the equation of a straight line when you plot a reduced viscosity with the concentration. Now, if you see this graph, now if you actually go towards the zero concentration, आपको extrapolate करना पड़ेगा इसको. So when you reach this point, you will get the viscosity of the solution when the concentration is zero. So what we'll do, we'll write it like this. So we'll write it specific viscosity by concentration when the limit approaches to zero. We'll show it when the limit approaches to zero. So that concentration value is, जो value यहाँ पे हमें मिलेगा at very low concentration, that's almost minimal, that's zero concentrations पे, zero concentrations, yeah, I should not say zero concentration, low concentrations पे, जहाँ पे it will actually cut this y-axis. So the concentration which you will get, the value of that concentration at, that is basically called as your intrinsic viscosity. So then you have a new term called as intrinsic viscosity. इस ग्राफ को एक्सट्रापोलेट करने के बाद the viscosity of solution which you will get at zero concentration, so that's basically called as the intrinsic viscosity. So वहां से क्या पता चला आपको? This is mx plus c. The c is the intercept. Fine. That means from this you could get the intercept, and that intercept value is basically, that is this intrinsic viscosity जो हमने यहाँ पे दिखाया. So now this equation can be written as a reduced viscosity is equal to by c plus this. So this is the straight line equation. So the value of intrinsic viscosity now can be calculated if you know. It can be obtained from, if you have a graph that this is y, you plot this y graph with respect to the concentration. So y versus c you can calculate from that graph. By extrapolating you can get this intrinsic viscosity. So from this this experiment which we will do, and finally we will end up with the intrinsic viscosity. Now from the intrinsic viscosity we can actually calculate the molecular weight of the polymer. Remember this. So from the viscometric method, it is basically the intrinsic viscosity. It is basically the intrinsic viscosity that's used to calculate the molecular weight. Intrinsic viscosity denoted by here like this. So that is used to calculate the number average molecular weight. Remember this. It's not the specific viscosity, it is not the reduced viscosity, it's not the relative viscosity, it is the intrinsic viscosity that is used to calculate the number average molecular weight, and that intrinsic viscosity is obtained from this relationship. Now how we can obtain the molecular weight? So that we can obtain from an important equation that's called as, remember this is very important, many times asked in the exam, it's called as a Mark-Having equation. ये बहुत बार आया है एंट्रेंस एग्जाम्स में, इवन गेट में, इवन नेट में. इट्स कॉल्ड Mark-Having equation. Mark-Having equation. It's HOUW rather. So what is that Mark-Having equation? That is your intrinsic viscosity that is equivalent to capital K molecular mass of polymer and A, where A and K are the constants, M is the molecular mass of the polymer, this is the intrinsic viscosity, this is your Mark-Having equation. Now intrinsic viscosity you can calculate from this relation. So what is K and A? These are basically constants. So both K and A, remember, they are constant for a particular solvent and polymer. जो भी solvent और polymer हमारे पास है जिसको हम स्टडी कर रहे होंगे, for that A and K will be constant. So if these are constant, you calculated this from this relationship, you can easily get the molecular weight of the polymer. अब इसको हम थोड़ा सा यहाँ पे solve करेंगे, then we'll close this our topic. So we can use here the log formula. If you apply log on both the sides, so we'll get the natural log of intrinsic viscosity that is equivalent to natural log of K plus A, fine, into natural log of molecular weight. Fine. Let's go, even no need bracket because it's already is a big term, so no need brackets. K plus A. So what you do, you need this molecular mass. अब इसको यहाँ पे लेके आ जाइए. So we'll get log of intrinsic viscosity minus log of K divided by A. That is your natural log of M. Fine. So this is your natural log of M. Now इसको हम यहाँ पे लेके आएंगे, that becomes anti-log. So then you have the molecular mass of polymer. That's the number average molecular mass So that can be written as the antilog of this whole term. What is that? That is your log of intrinsic viscosity minus log of constant K divided by A. And so this is the equation with the help of which you can calculate the molecular weight of a polymer, where A and K, they are constant for a particular solvent polymer pair. Intrinsic viscosity will be calculated from that graph, which was the straight line equation. So you will end up with the molecular weight of polymer, that is the number average molecular weight. So this was all about the basics, the cracks, जिसमें एग्जाम में क्वेश्चन पूछा जाता है about the viscometric method or viscosity method for calculating the number average molecular weight of polymer. So in the next lecture we'll be having some more methods like light scattering method and others. So this is all for the day.